example 2 says use the zeros and the end behavior of the polynomial function to sketch an approximation to the graph of the function. So first we have before we do that, let's define what we mean by zeros. Does everybody know what the zeros of a polynomial function are? X-intercepts. Very good. Okay. So the zeros of a polynomial function are where the x-intercepts are located. And the x-intercepts are where the function equals 0, right? Or y is equal to 0. You know, when we find the x-intercepts in the graph of an equation, right, we set y equals 0 and solve for x. Okay. So at the zeros, the graph crosses or touches the x-axis. Right? That's the definition of an x-intercept. Okay. All right. So the first function we have is f of x is equal to minus x cubed plus 4x. It's a polynomial function. What's the leading term? What is it? What's the leading term? Negative x cubed. So minus x cubed is the leading term. And on page 1, we learned that from the leading term, we can determine the end behavior in the graph of this polynomial function, right? So what's going to happen on the left hand? It's going to go up. What about the right end? It's going to go down. So we already know in the graph of this polynomial function what it's going to look like on the left end and on the right end. Okay, just from the leading term. All right, now to find the x-intercepts, you set the right-hand side equal to 0. Solve for x. So I can factor out an x, right? Each of these terms have x in them, so I can factor out x. But more specifically, I can factor out a minus x. Right? Because I distribute the minus x times x squared is minus x cubed, and minus x times minus 4 is plus 4x. Okay. And now x squared minus 4 can be factored into x minus 2 times x plus 2. And now I set each factor equal to 0, right? And so x, well, I guess we'll write minus x can equal 0, x minus 2 can equal 0, x plus 2 can equal 0. And so when you solve these, x is equal to 0, x is equal to 2, and x is equal to minus 2. So that's the location of 3 x-intercepts. Okay. And those are also called the zeros of the polynomial function. Okay. Now remember, we're just approximating the graph. So the 3 x-intercepts are located at minus 2, the origin, and plus 2. Okay. Now, we already know that the graph is going to go up on the left hand. So from this x-intercept on the left hand, far left hand x-intercept, right, the graph has to go up. And from this x-intercept at x equals 2, the graph has to got that from the leading term. And now the question is, what does the graph look like in between? Well, we haven't talked about multiplicity of zeros yet, but each of these, the exponent on each of these factors is 1. We've got x to the first, x minus 2 to the first, x minus 2 to the first. So at every one of these x-intercepts, the graph crosses the x-axis. And we just talked about turning points, right? So starting on the left side here, the graph has to cross the x-axis, form a turning point, come up and cross the x-axis at x equals 0, form a turning point, and come down and cross the x-axis at x equals 2. Okay. So we have a turning point right here, and we have a turning point right here. And so that's a rough approximation, okay, to the graph of this polynomial function. Okay. Any questions on that? All right, next we have f of x is equal to x to the 4th minus 5x squared plus 4. What's the leading term? Yeah, x to the 4th is the leading term. So on the left end, does the graph go up or go down? Up. What about the right end? Up. So it goes up on both ends, right? Like a parabola. Now, the hard part is finding the zeros, okay? So we set the right-hand side equal to 0. We got to find the values of x that make the left-hand side equal to 0. Well, you notice this is not a quadratic, right? But it is quadratic in form, okay? If instead of x to the 4th and x squared, if we had x squared minus 5x plus 4, you would know how to factor that, right? That factors into x minus 5 times x minus 1. Well, we call this quadratic in form. This factors into something similar. But instead of x minus 5, we have x squared minus 5. Instead of x minus 1, we have x squared minus 1. So this actually factors into x squared minus 5 times x squared minus 1. And when you FOIL this, you end up with x to the 4th minus 5x squared plus 4. Right? You can verify my factors by FOIL. Okay. So this 4th degree polynomial factors into x squared minus 5 times x squared minus 1. Oops, I did that wrong. What's that? Did I do it wrong down here? Yeah. Yeah, so, yeah, thanks for speaking up. Okay? So, right, what I meant to say, this is x squared minus 5x plus 4. Then this factors into x minus 4 times x minus 1, right? You guys got me spooked. Is that correct? So then this factors up here, since it's quadratic in form, into x squared minus 4 times x squared minus 1. Okay? Does that make sense? Have I made a mistake? No? Okay. I'm counting on you to speak up when I make a mistake. So, well, x squared minus 4 factors, right? factors in x minus 2 times x plus 2. And x squared minus 1 factors in x minus 1 times x plus 1. Now you guys know why I stand up here with my notes in my hand. Okay? So I can catch myself when I make a mistake. Alright. Well, so what are the zeros of our polynomial function? Just set each of these factors, right, equal to 0. And then solve for x. And we get the x-intercepts are located at x equals 2, x equals minus 2, x equals 1, x equals minus 1. So we got 4 x-intercepts. Now, we can also, when we graph this thing, we can also include the y-intercept. And how do you find the y-intercept? You plug in and put in 0 for x, right? So you set x equal to 0 and solve for y. So when we put 0 in for x on the right-hand side and solve for y, we get y is equal to 4. So y-intercept. So now let's draw a coordinate plane. And so here's x equals 1, here's x equals 2, minus 1, minus 2. And then here's like y equals 4 up here. That's where the y-intercept is. So we know that the graph goes up on the left end. So from this far left y-intercept, the graph goes up. And on the right end, the graph goes up. So from this far right x-intercept, the graph goes up. I hope I said far left x-intercept is minus 2, the graph goes up. And far right x-intercept, x equals 2, the graph goes up. Okay. Well, again, we haven't talked about the multiplicity of zeros, but each of these factors is to the first power. So the graph crosses the x-axis at each x-intercept. So starting here on the left, the graph comes down, forms a turning point, then goes up, crosses the x-axis at x equals minus 1, and then comes all the way up here to the y-intercept, and then comes down, crosses the x-axis at x equals 1, forms a turning point, comes up and crosses the x-axis at x equals 2. And that's our crude graph of this polynomial function. Okay. It's actually supposed to be symmetric to the y-axis. Okay. Any questions on any of this? What we just did. Okay. Let's take a look at number 3, example 3. Example 3 says find a polynomial function with leading coefficient 2 and zeros at minus 3, minus 1, 3, and 4. So let's observe something from this previous problem. Okay. In finding the zeros, right, the x-intercepts in the polynomial function, if x minus 2 was a factor, then x equals 2 was a 0, an x-intercept. We go in reverse. If x equals 2 is an x-intercept, then x minus 2 is a factor of the polynomial. Okay. So we're given x equals minus 3, x equals minus 1, x equals 3 and x equals 4 are the zeros or x-intercepts in the graph of this polynomial function. Okay? And so, given what the x-intercepts are, we can now figure out what the factors are. Okay? And so, if x is equal to minus 3 is a 0, then when you add 3 to both sides, you get x plus 3 is equal to 0. Over here, you add 1 to both sides, you get x plus 1 is equal to 0. Subtract 3 from both sides, you get x minus 3 is equal to 0. Subtract 4 from both sides, you get x minus 4 is equal to 0. So I'm just going backwards with this problem. Started here, now we go up to here, and now we go up to here. Okay. So it has to be true that x plus 3 times x plus 1 times x minus 3 times x minus 4 is equal to 0. In finding the zeros of this polynomial function. And this product, right, this factored polynomial has to equal f of x. Because when we find the zeros of f of x, we set the right-hand side equal to 0. So the polynomial in factored form is f of x is equal to x plus 3 times x plus 1 times x minus 3 times x minus 4. That is the polynomial in factored form. You just call it factored polynomial. So if I gave you this polynomial and I asked you to find the x-intercepts for this factored polynomial, you would set the right-hand side equal to 0, and then you would set each factor equal to 0, and then you would solve for x to get the x-intercepts. So we just went in reverse. Okay? But I left out one very important thing in this problem. We are given that has a leading coefficient of 2. What I have written on the board here, the number in front of this factor is the invisible 1. So the leading coefficient for this factor polynomial is 1. I got to put a 2 there so that the leading coefficient is plus 2. That factored polynomial has a leading coefficient of 2. The number up front here is the leading coefficient.
I have a question about the equation. So, can you condense it even more?
This on the right-hand side,
Just like the whole problem.
you could FOIL.
And then,
You can expand it. And you would have like x times x times x times x, x to the 4th. So we have a 4th degree polynomial, x to the 4th times 2. So the leading coefficient, or leading term, is 2 times x to the 4th.
yeah. I was just wondering if, like, on the test, we're going to have to condense it back. Because I see, like, a difference of squares. Like,
Yeah.
like just to, like,
Yeah, I mean, I don't want people, that would be
is that too
horrible.
much?
That would be a nightmare to grade.
Okay.
Everybody would have a different answer, you know? So, I mean, you have to be able to multiply 2 factors, right? And maybe 3, but I doubt I could ever imagine having 4, right? Yeah. All right. So the number out in front is the leading coefficient. Okay. before I put the 2 there, the leading coefficient was the invisible 1. Now it's 2. Okay. All right. Any questions on that? All right. So now let's talk about the multiplicity. And so what this little bit here at the bottom says, if a polynomial has a factor of the form of x minus c to the k power, where k is an integer greater than 1, then x equals c is a repeated 0 of f of multiplicity k. So we'll demonstrate that on the next page. And so what it says here is if k is even, right, if the multiplicity is even, then the graph flattens and just touches the x-axis at x equals c. So let's say I have polynomial function f of x is equal to x minus 2 to the 4th power. Okay? What that is saying is that either the graph is going to come down and touch the x-axis from above, or it's going to come up and touch the x-axis from below. In this case, it's going to touch the x-axis by coming down from above. Okay. So this is where the exponent k is even. The second situation, right, says if k is odd, you're going to have one of 2 situations with the x-intercept. The graph is either going to come down and cross or come up and cross at the x-intercepts. Okay. So if k is an even integer, then the graph is just going to touch the x-axis and stay either above or below. But if k is an odd integer, then the graph is going to cross the x-axis, okay, either from above or below. So let's demonstrate that with the examples on the next page. And you might want to draw a line down the center of the page. Because we got two examples. So in A, the polynomial is unfactored in standard form. In B, this is a factored polynomial. So we have f of x is equal to x to the 4th minus 3x cubed plus 2x squared. All right, what's the leading term? Do we know the leading term? Yeah, x to the 4th is the leading term. So is the graph going to go up or down on the left end? What about the right end? So we already know the end behavior, right? Now, to determine the zeros and the multiplicity, we set the right-hand side equal to 0. Solve for x. So you can see we've got 3 terms all involving x. So the smallest power of x is 2, so we can factor out an x squared. So we have x squared times x squared minus 3x plus 2. That quadratic factors. It factors into x minus 2 times x minus 1. And now we set each factor equals 0 and solve for x. And we get x equals 0 with multiplicity of 2. Okay. So this is x squared. And then we have, when we set x minus 2 equal to 0 and solve for x, we get x is equal to 2. And this is x minus 2 to the first power. That's x minus 1 to the first power. So x equals 2 is a 0 with multiplicity of 1. And then when you set this factor equals 0, x minus 1, so for x, we get x is equal to 1. And it has a multiplicity of 1. So now we can graph the polynomial function. Right, has x-intercepts at x equals 0, x equals 1, and x equals 2. Right. We know it goes up on the right end, so from that x-intercept at x equals 2, we know the graph goes up. And it goes up on the left end, so at this x-intercept at x equals 0, it's got to go up, right? Deductive reasoning, a lot of deductive reasoning in this graph. Now, the multiplicity is even at x equals 0. So at x equals 0, does the graph cross the x-axis, or does it touch it and go back up? It goes back up. So you gotta get the graph and drawing correctly, right? So it comes down, and you have a turning point at x equals 0. Right? The multiplicity is even, so the graph comes down and touches the x-axis, x equals 0, and goes back up. Now we have an x-intercept at x equals 1, and because the multiplicity is odd, we know the graph is going to cross the x-axis at x equals 1. So it comes up, forms a turning point, and then comes down and crosses the x-axis. And the multiplicity at x equals 2 is odd. So, and the graph goes up on the right end. So we know the graph comes down, forms a turning point, comes up, crosses the x-axis at x equals 2. And so that is a crude sketch of the polynomial function. Okay. Any questions on this? All right, so let's take a look at B. We have f of x is equal to the negative of x minus 4 cubed times x minus 3 times x plus 2 cubed times x plus 5 squared times x minus 1 squared. Got to copy everything down correctly. I think I did. What's the leading coefficient? -1, right? The number up front here is -1. Very good. Yeah. So, define the zeros, or the also known as the x-intercepts. You set each of these factors equal to 0 and solve for x, right? So we have x minus 4 cubed is equal to 0. We have x minus 3 is equal to 0. I guess I can drop parentheses. We have x plus 2 cubed is equal to 0. We have x plus 5 squared is equal to 0. And we have x minus 1 squared. All right. So in this first equation, right, you can take the cube root of both sides and you end up with x minus 4 is equal to 0, which means x is equal to 4. Right? In the second one, you just end up with x is equal to 3. In the third one, take the cube root of both sides and subtract 2, you get x is equal to minus 2. In the fourth one, you take the square root of both sides and subtract 5, you get x is equal to minus 5. And in the bottom one, you take the square root of both sides and add 1, you get x is equal to 1. Now I'm going to create a little table with 2 columns. The first column contains the 0, which is also the x-intercept. And the second column contains the multiplicity. So our x-intercepts are zeros. Our x equals 4, 3, minus 2, minus 5, and 1. The multiplicity is the exponent on the factor. So on this factor x minus 4, right, this is x minus 4 cubed, the exponent is 3. That's the multiplicity. The 0 x equals 3 has a multiplicity of 1, right, because just x minus 1 to the first power here. The 0 x equals minus 2 has a multiplicity of 3, right, because we have x plus 2 cubed. The 0 x equals minus 5 has a multiplicity of 2, right, because it's x plus 5 squared. And the 0 x equals 1 has a multiplicity of 2 because it's x minus 1 squared. Yes, ma'am.
Does the negative in the function not distribute to the other?
Here? Here?
Yeah.
No. Not in finding, not setting the right hand side equal to 0. It's all correct. So that's no effect. Okay. So multiplicity of 3 and 1 are odd, not integers. So we know at these 3 x-intercepts, the graph is going to cross the x-axis. Multiplicity of 2. 2 is an even integer. So we know at x equals minus 5 and x equals 1, the graph is going to touch and turn. It's not going to cross the x-axis. The graph is going to cross at those 3 zeros and touch and turn at those last 2. Okay. All right. Now, she brought up an interesting question about the minus sign. So the leading coefficient, what's the leading coefficient in this problem? minus 1. Now, to find the degree n of this polynomial function, you have two choices. You either add up the multiplicities, 3, 4, 7, 8, 9, 11, or you add the exponents. 3 plus 1 plus 3 plus 2 plus 2 is 11. So the degree of this polynomial function is 11. The leading term, a times x to the n, right, is the leading term, but that's the form of leading term, where a is the leading coefficient. Well, the leading coefficient in this case is minus 1, n is 11, so minus 1 times x to the 11th power, which is the negative of x to the 11th, is the leading term. So given the leading term, does the graph of our polynomial function go up or go down on the left end? On the left end. This is minus, this is negative. On the left end, x is negative. And negative raised to the 11th power is negative, right? So it's negative times negative, which is positive. So it's going to go up on the left end. What about the right end? So now we know the x-intercepts, the behavior at the x-intercepts, and the end behavior. So now we can draw a crude sketch of this graph. Okay. So, and I provided a coordinate plane, but you know what? See if you can come up with a crude sketch for class on Wednesday. And then we'll put it on the board for Wednesday and compare graphs. Okay? So have a good day, and I'll see you Wednesday.